Manager of the Coral Conservation Program at the Florida Aquarium. I'd like to thank the organizers of Palooza for having me out here today to talk to you, and to Richard Back and Shane Lafreniere for actually connecting me with the Palooza team all the way back in 2019, and I was supposed to talk in 2020, but COVID had different plans for all of us, so I'm glad to finally be here in person to speak to everybody about our work. A little bit about me. This is a very embarrassing picture of my first reef aquarium in 1999, and as you can see, it pretty much had everything wrong with it. It had an undergravel filter and a whisper hang on the back filter, but it did all right, and everybody has to start somewhere, so I hope I can inspire somebody here today who's just starting in the hobby that you can actually make this your career and can actually become a coral scientist and save corals in the wild. After I went to University of Maryland and got my bachelor's degree in biology, I actually got a job at the National Aquarium in Baltimore as an aquarist, and there I worked my way up to take care of our 7,000-gallon Indo-Pacific coral reef tank, and that's me cleaning the window, and I did that every week for about 6 years. And then I also worked with a wide variety of other exhibits, freshwater, saltwater, all shapes and sizes, and got a really great education in life support systems and large-scale life support systems and how they're engineered. And that's something I still really enjoy to this day, is designing new systems and figuring out how to make your filtration work for you. But really my passion was with that reef tank. And I actually was really lucky to get the opportunity to partake in a Sea Corps workshop in Puerto Rico in 2008. And it was this workshop that really changed the course of my career. I got to go down to Puerto Rico and help collect spawn from the Atlantic elkhorn coral. And this was my first time seeing coral spawning in the wild. And I was taught how to fertilize those eggs and raise larvae and actually put them back out onto the reef. And at this time, this was really just a bunch of aquarists from public aquariums around the country who went and descended on a rental house on the beach in Rincon and rigged up a flow-through seawater system and raising coral babies in literally a kiddie swimming pool. But it was a really interesting and fun experience. And I brought those larvae back to the National Aquarium and settled them on some frag plugs. And I actually had about 3,000 elkhorn coral babies, and I was so proud of myself. And this one right here, actually you can see, had just gotten its symbiotic algae. So when the coral first settles, it doesn't have a symbiotic algae in its tissues. It needs to get it from the environment. And this is what makes you really nervous when you're growing baby corals, is whether they're actually going to take up those symbionts or not. So as soon as I saw this, I was like, yes, they got their symbionts. This is going to be great. I'm going to raise some elkhorn coral. But unfortunately, that coral right there is the only one that ever took up its symbionts. And over the next 3 to 4 months, I watched all of those little corals slowly perish. However, that was not a failure. That just motivated me to try again, and I decided that I would actually leave the aquarium and go back to graduate school, and I moved down to Florida and went to Nova Southeastern University. I had been talking to a professor there who said they had a land-based coral nursery, and they were growing corals in tanks to put back in the ocean. And I was like, well, that sounds amazing. I love growing corals. I know how to take care of aquariums. This sounds like a perfect opportunity for me. And I got there, and there was sort of this rudimentary flow-through system from a saltwater well, and it had 4 trays and this little shade hut right on Port Everglades. And the way this system works is that when the temperature got too high or too low, that well pump would turn on and just flow nutrient-enriched, low pH, organic loaded salt water through the system and then right out the drain into Port Everglades. And there was tons of algae in this tank, and the corals were alive, shockingly enough. They just weren't growing very well. And then shortly after that, I learned that this flow-through system from this well was not enough to maintain temperature when it got really cold. It does actually get cold in Florida, and in 2010, it got down into the 30s at night in Miami and Fort Lauderdale. So what do you do when your tank in Fort Lauderdale is sitting at about 65 degrees and not able to maintain temperature? You call 24/7 aquariums, and they manage to get you like 6,000 watts of heat on, a half a day's notice, and you rig it up on every circuit that you can find. And I managed to use this incident to get the higher-ups at the university to actually invest in a heat pump for this system and make it fully recirculating. And after that, finally, those corals started to grow. So we were primarily growing a Cropera cervicornis in these tanks at the time, and really the mission was to put them back in the ocean. So the big question with this research was, will these corals do well after being raised in a recirculating aquarium for up to 18 months to 2 years? Will they actually be able to adapt when they go back out into the ocean? And a lot of scientists thought they wouldn't. They're like, oh, they're going to be so adapted to being in a tank that they'll just die when you put them back in the ocean. But I feel like everybody in this room knows that what we strive for in our aquariums is try to make them as much like the ocean as possible, and that ensures that our animals are healthy. And sure enough, those corals did just fine when they went back out into the ocean. So I was feeling pretty good about myself. I got my master's degree and I went and worked at an environmental consulting firm. And I was diving all the time, monitoring reefs out in the wild. And I started to see this happening right in front of my eyes. And what we didn't know at the time is that this was the beginning of the largest coral disease outbreak ever recorded. At the time, we were calling it white plague, or a new kind of white plague. What it is now called is stony coral tissue loss disease. And this map shows how this disease has spread through the Florida Reef Tract, starting in Miami in 2014, and then going northward and southward from then until it reached the dry tortugas in the end of 2021. So this is now found across Florida's coral reef, and now multiple other locations in the Caribbean as well. And this disease is nasty, especially to the Atlantic pillar coral. Stony coral tissue loss disease is a super creative name because basically it just causes the tissue to fall off of stony corals. So that's basically what's happening in this photo, is this tissue is just peeling back, and in a matter of less than a year, this entire colony has died. And it's not just the pillar coral. Unfortunately, it impacts 22 different species on our reef. The pillar coral and the maize coral are hit very, very hard. We've lost over 90% of those individuals on Florida's reef. And right about that time, I saw this job advertisement for the Florida Aquarium Center for Conservation. And I said, you know what? This is a place that wants to use their aquarium knowledge and husbandry to actually grow corals to help prevent extinction and promote the health of our reef. And I said, I think I actually would rather do that. I'd like to go there, and I had the chance to develop this center. When I first started, there was just one little greenhouse in this modular office, and I would ride a four-wheeler from there to there. There wasn't even really a road, and take care of the corals that were in that first greenhouse. This is a 20-acre property owned by the Tampa Electric Company and rented to the Florida Aquarium for $1 a year so that we can do our conservation and research work. And then we also have partners from Florida Fish and Wildlife Conservation Commission on site and the University of Florida. So over time, we grew to 3 greenhouses. And inside of those greenhouses, we've engineered a bunch of different custom designed life support systems for holding broodstock corals and also rearing offspring from coral spawning. And the first species we worked with there was the pillar coral. So in about 2016, scientists and regulatory agencies realized that these corals were dying, that there was a very real risk that we were going to lose all of them in the wild in Florida. So they started taking them off the reef. They started just taking fragments of every colony they could find and putting them into aquarium systems for safekeeping. And unfortunately, at that time, they were being taken off the reef from sites that were actively diseased with stony coral tissue loss disease. So they would come into our aquarium and actually start to show disease signs. And these were very, very specific symptoms. It wasn't just like normal rapid tissue loss. You would get a spot that had no polyp extension, that then turned pale, and then spread in a very circular fashion from that center lesion. And this is another place that the hobby has helped immensely with coral conservation, is that we had something to try to do about it. We knew about Lugol's dips. We knew about Coral RX. We knew about Revive. We could actually try to dip these corals and save them from dying. And it did stem off that disease a bit to dip the corals, but ultimately we worked with some scientists from NOAA who were trialing antibiotics with these corals. And between the scientists at NOAA, us at the Florida Aquarium, and a partner at a pharmaceutical formulator in Clearwater, we developed the first topical treatment for stony coral tissue loss disease. And this stuff actually releases amoxicillin over a 3-day slow release profile into a mucus membrane. So it's a targeted delivery system for stony corals. As we all know, they're very mucousy on their tissues. And it's pretty crazy, but that actually got permission to be used in the wild. So that 22,000 corals in Florida were actually treated with this treatment. And people are using it all over the Caribbean now as well to try to stop stony coral tissue loss disease. Now, it's still a drop in the bucket. You can't treat every coral out there, but what you can do is at least save enough corals that you have enough parents left over to hopefully make babies in the future. So after we got that treatment, everything really started to settle down, and we made a lot more improvements to our life support systems, and we have now a very thriving genetic bank of living pillar corals. But unfortunately, in the wild, this disease just didn't stop. So as of right now, there are only 24 genetic individuals from this species alive on Florida's coral reef. 4 of them are diseased, and the other 20 are less than 5% of their original size, and most of those were saved with that amoxicillin treatment. And this leads scientists to call them functionally extinct. So what does that mean, functionally extinct? Imagine this was the population when you started, and then you lost 90% of them. Now when they reproduce every year, mom may never find dad, and you can't make any offspring. So this is actually, in this diagram, these would be able to make offspring, but we have even less than that for pillar coral. So it is believed that in the wild, there will be no more pillar coral babies produced without human intervention. So we needed to do something creative with our living genetic bank. So we contacted Jamie Craggs at the Horniman Museum. You guys may have seen his talks or heard about him. He's been doing amazing work spawning corals from the Indo-Pacific and had spawned 12 or 13 different species of Acropora from the Indo-Pacific at this time. So we reached out to him and said, hey, could we do this with Atlantic corals? And of course, Jamie's like, sure, you can. So I went over to London, and Jamie came over to our place, and we decided to build 4 of these systems, and these systems really use technology developed for the hobby. It is an apex system and radion lights, and we could not do this if that technology didn't exist. So we were building a sea turtle rehabilitation center at the time, and luckily my boss was like, sure, we can put corals in there. So we built 2 dark rooms and 4 spawning systems over 2017 and 2018. And this is what those systems looked like when they first got set up in early 2019. And the first species we put in there was the pillar coral. And then in August of 2019, this happened. So those were both female pillar coral colonies releasing eggs. Pillar coral is what's called a gonochore, so the male and female are separate. So both of these are females releasing eggs, and the males spawn in a similar way and release sperm out into the water column, and all that fertilization happens externally, and then they develop into these tiny little swimming larvae. So that first year, we actually made several million pillar coral larvae, which was pretty unheard of. Even when you try to do this in the field with pillar coral, it's very, very difficult, and you'll be lucky to get a few thousand good larvae. And right at the end of 2019, the state regulatory agencies said, hey, that pillar coral rescue project worked pretty well. Why don't we do this for all the other disease-affected species? And they started what's known as the Florida Coral Rescue Project, or the Florida Reef Tract Rescue Project. And this was a partnership between AZA, the Association of Zoos and Aquariums, which is an accreditation agency for zoos and aquariums across the country, and FWC, the Department of Environmental Protection, and NOAA. And they started to collect corals from areas where the disease hadn't reached yet. So at that time, that was like the Lower Keys, the Marquesas, and the Dry Tortugas, and send them all over the country to public aquariums for safekeeping. So we currently have 20 different holders and are holding over 2,000 corals at these aquariums. And this is just, there's actually more now. It's just massive effort, takes tons of different partners, funding agencies, the regulatory agencies, universities, nonprofits. This was a really great example of how collaboration and fast action can actually make a real difference in saving species. And the fact that we had this aquarium husbandry knowledge. If we didn't know how to keep corals in aquariums, we would not have been able to save these corals. This is the coral rescue dashboard. So as you can see, there are 2,300 corals under care, and these are all the different facilities, and this you actually scroll down. This is publicly available if anybody wants to keep an eye on it and see if we're getting more corals in the collection and where they are. And these are some of those other rescue species at the Florida Aquarium Center for Conservation. Most of them live out in our greenhouses. Some of them live in our dark spawning lab under LED lights. But we have been now working on spawning all of the different species that we have at our center. So our second one was the maize coral. This is Meandrina meandrites. This one also was in 2019. This one's a male, so you'll see what that looks like. And this one's one of my personal favorites, the grooved brain coral, or Diploria labyrinthiformis. This one will actually be spawning here in a couple weeks. It's the only species we have that spawns well before sunset. So this is actually what it looks like. This is not sped up. And the lights are still on at that level. And actually, this is in the induced spawning lab, so the spawn timing is really tight. So we'll have 10 individuals sitting next to each other, and they'll all spawn like that within about 15 minutes of each other. It was very cool. And then most recently, we finally had success with the Atlantic elkhorn coral. This coral is horrible to keep in an aquarium, by the way. Most scientists thought we'd never be able to do that. If you want to know all about it, talk to Rachel Seraphin. She's sitting over there. She's the one that actually takes care of all the elkhorn coral fragments in our spawning systems. So how does this work? As I said before, it's using a Neptune apex. This was the original way to do that. And then now we are working with Ecotech and Aperture to develop a control system that works in Mobius now that we have the newer generation of radions that don't work with the apex, but you know how it goes. And it really was the apex season table that allows this to happen. I don't know whose idea this was to put this in the apex, but whoever it is, I'd like to buy them a beer because you made all of this happen. And in here, you need to put the sunrise and sunset on the first day of the month, the moonrise and moonset on the date of the new moon, on the first day of the month, the date of the new moon, and the temperature on the first day of the month. And all of this is available online. Just go to timeanddate.com. You need to pick what place in the world you're trying to replicate. So if you want to do this with a coral from Australia, you want to pick somewhere in the Great Barrier Reef that coral could be found, and that's the GPS coordinate that you want to put in, or the city or town, in timeanddate.com, and look up all this information. So it's not rocket science. It's all available online. And the temperature profiles you can get from a variety of sources. There's NOAA buoys that record temperature. You can even follow like a dive operator's website that says, this is what the temperature is today. It doesn't have to be perfect. The only thing this season table doesn't do is change the intensity of the light over the course of the year. So the sun is more intense, and actually you'll have a higher incident PAR level on the surface of the ocean in the summer, and then it's slightly less during the winter. So you also need to account for that in this program. But what we've been doing is changing that peak intensity manually, either every 2 weeks or every month. And ours will ramp up to about 70% in the summer, and it'll be down at 50% output in the winter. And I'm very excited that actually all of these brands are now under Aperture, because we've been talking a lot with them about making all of this work together again and really give a user-friendly way to promote coral spawning in everybody's aquariums. If you want to know more detail about this, the information is already out there. So Jamie Craggs has spoke on this at multiple conferences. Richard Ross is doing this and has spoken on this at multiple conferences. A lot of them are available online, usually from MACNA Talks. And there's also 2 publicly available scientific publications. This was Jamie's in 2017, and this is mine and my staff in 2021. The key with these is to look at the supplemental information. So you can read this whole scientific paper and you're still be like, I don't really know what they did. Go into the supplemental information and there's literally screenshots of our season tables and screenshots of the programming in the apex. And a lot of people miss that. So after the spawning happens, then what do? You collect those gametes out of the water and place them into some sort of container. Depending on how much spawn you have, you might just be using a gravy separator or a small bowl, or you might need a large cooler. And as those bundles of sperm and eggs break down, that water gets fouled very, very quickly. So you have to dilute it, and then the fertilization occurs within the first hour. So what I'm doing in this picture, these bundles have broken down, the eggs are floating on the surface, and as you can see, the water below is very cloudy. You want to get that diluted down to the point that you can at least see through it, and then you can leave it sit for about an hour to fertilize, and then keep rinsing it, rinsing it, rinsing it. After fertilization, those eggs start dividing, and they go through this cycle of embryo development. And they're really fragile at this stage, so you want to get all that rinsing done before they start dividing. Because if you start pouring these or scooping them or putting them under aeration, they just start to break apart, and then you end up with really small and unhealthy larvae. So ideally, you want to get them into just a container where they can just sit stagnant for 24 hours while they go through these cell divisions. And this full process to get to a swimming larvae can actually take up to 5 days. Sometimes it's 24 hours, in some species, Acropora mostly, it takes up to 5 days. And once they're looking like this, we call this directionally swimming. These little guys are ready to find a home. They're looking for a chemical cue that tells them, this is a coral reef and this is where I should live. And that chemical cue comes from crustose coral and algae. So that pink calcified algae that we have in our reef tanks, that's what those coral babies like. It's actually a bacteria that is associated with that algae that releases a chemical that baby can cue in and go, okay, now it's time to settle and turn into a primary coral polyp. But as I said before, getting the symbionts is the tricky part. So what I think happened back in Baltimore with my first set of elkhorn coral was that I didn't have the right type of symbiont. I didn't have any elkhorn coral or Atlantic coral of any kind at the aquarium because it was illegal to keep them. And turns out that the Atlantic elkhorn and staghorn coral carry a very specific type of symbiont that generally isn't found in Indo-Pacific Acropora. So it didn't matter how many branches of Acropora I put in a blender to try to get the symbionts into these little corals, they were just never going to take them up. So what we do now is settle these corals in a system where there are fragments or adult pieces of the same species, or at least the settlement tiles that these larvae will settle onto have been seasoned with adults of the same species. So as I said, they like the coral and algae. These are the tiles that we can just condition in our sumps so they get a nice biofilm and coral and algae on them. And then we'll put 5,000 to 10,000 larvae into one of these dish pans. It's very fancy from Dollar General. And we've drilled holes on the sides and have 150 micron mesh. So we'll put the larvae in there and they'll swim around and turn into a primary coral polyp. And usually if the tile's good, they all want to be there. So you'll get like 100 tiny little corals on one square and then none on another square. And when they all start to grow and have good survival, then they all just start to run into each other. So now you have a problem where you need to separate them. So the staff that work at the Center for Conservation are really good with tile nippers and small stainless steel clippers and bandsaws and separate thousands and thousands of these baby corals every year. And we've really been working on now trying to maximize the survival of these corals and improving growth. So the faster we can get these things to be about an inch in diameter, the sooner they can go back out onto the reef. So we're really careful about our water quality. Because this relationship between the coral and its symbiont is still very new, you don't want to stress that relationship. They can very easily bleach, they can very easily die and get tissue loss. So we really pay attention to this nutrient ratio concept where we have our nitrogen always a bit higher than our phosphorus. Generally in our systems, our phosphate is around 0.03 to 0.07 and our nitrate is around 1 to 1.5, and that seems to be a happy spot for the coral babies. And low DOC is also important. This is something that you can't test very easily in the hobby without sending the Triton NDOC test, but we found that it does actually really matter because dissolved organic carbon feeds bacteria. And you know this, if people are carbon dosing, that's why you're doing it. You want those bacteria to grow because then they use up some nutrients when they're growing. But it can also feed negative bacteria. And these little babies don't have a very strong bacterial community. They're just forming that. So I think that they are extra sensitive to shifts in bacterial community in the tank. They don't need very much light at first. Again, they don't have a ton of symbionts. You don't want to stress out the symbionts. So we start them at 50 or even less. And then over the next couple months, as they start to get nice color to them, we'll increase that to 300 to 400. We do target feed them for the most part, just taking a pipette or a baster and going across each row of babies, and that really improves their growth rate. And as I said, the sooner you can get them to a bigger size, the sooner they can sort of take care of themselves and have a higher survival and get back out on the reef. And we do use a lot of grazers and herbivores to clean around these corals and then regularly clean them by hand as well. You can't really use like full-size urchins, and sometimes even you can't use like a full-size lithopoma snail. You also really need baby urchins and baby snails. So another thing we do at our center is culture juvenile sea urchins. We're raising Diadema antillarum, Lidocynus variegatus, and Trypnustes ventricosus, and those are great for cleaning around those little corals. And we're also working on spawning lithopoma snails on purpose. You guys may have had snails spawn after you do a water change, and that happens to us as well, but we're trying to figure out how to make that actually happen like in a controlled fashion. So if anybody has any tips on that, chat with me afterwards. And really what makes the difference between this project and what I had done back in 2008 is that we have a whole team of people at the Florida Aquarium who are dedicated to just working on growing corals for restoration. And they don't have other exhibits to take care of. They don't have another full-time job and just get to do conservation work on the side. This is their job, and they are fully dedicated to the success of these corals. And now it's just a string of baby pictures because baby pictures are fun. So these are baby pillar coral. This is what we would call a toddler pillar coral. So this is actually from 2020. So it does have some decent size to it now. These are definitely the slowest growing one that we work with. These are Musa angulosa, the spiny flower coral. This grows up to kind of look something like a lobophilia. Copophilia natans, Acropora cervicornis. And these like little bunt cakes are Mycetophilia lamarckiana. And it's pretty crazy every time I do a presentation, this number kind of goes up a little bit, but we are over 200,000 offspring now that have been born and settled and raised and put back out into the ocean from our center. And a lot of people ask me, okay, like I want to do this. How do I raise corals that can go back out into the ocean? And there's a ton of regulations that go along with this. So to get the corals in the first place is heavily permitted by FWC and the Florida Keys National Marine Sanctuary and NOAA. And then once you kind of get the approval to keep them, there's a lot of guidelines that you have to follow in terms of their receiving and care. And then they also have a lot of data collection that goes along with them. So we have to do the quarterly health assessments on everything. And that all has to go into a database on their condition that goes to FWC. And then we follow very strict biosecurity and disinfection protocols. And then any exchange between nurseries is also regulated, as well as the transport and release. So if you are not somebody who likes to follow the rules, then this is not the job for you. But it is possible. Biosecurity. This is a concept that I think a lot of hobbyists aren't familiar with. And for us, this means that everything in our systems has to originate from Florida. What we don't want to happen ever would be that we are the ones that are responsible for accidentally releasing a parasite or an invasive algae species or something unknown into the Florida ecosystem. So we have to be very, very careful that these corals are never exposed to anything from outside of Florida. So all the live rock, all our cleanup crews, everything comes from Florida waters. And we're lucky here in Florida. We have a lot of vendors that can do that for us. In some places in the world, this is much more difficult, but in Florida, this is pretty doable. And not only does it have to come from Florida, but I have to ensure that the person that took that live rock from the live rock farm didn't then take it back to their distributor's place and put it in a tank with a bunch of Indo-Pacific fish before putting it in the box before it came to us, because that can definitely happen. So the collectors that we work with know very well that they need to keep the rock and the snails and everything that comes to our facility completely separate from any other organism from outside of Florida. And disinfection is very, very important. We also have corals at our center that have never been exposed to stony coral tissue loss disease, as well as corals that have been exposed to stony coral tissue loss disease. So we have strict disinfection procedures for our equipment and the way we wash our hands, and making sure that we're not cross-contaminating between different systems. And also, if you have a pre-existing aquarium that is going to then be used for Florida corals, there are very specific disinfection procedures to remove the biofilm from that aquarium and clean the inside of the piping and make sure that you're killing off all bacteria before it's used for corals for restoration. And then those corals have to get a health certification, and this is probably the weirdest part of it all. These baby corals have to be looked at by a veterinarian and given a health certificate before they can go back out in the ocean. And there are actually only 5 humans in the state of Florida that are approved to do such a health inspection on corals for release out into the ocean. There will be a 6th here in a couple of weeks. One of those individuals is in this room, Charlie Gregory, sitting in the 3rd row. So a land-based coral nursery that is a type of permit under FWC to be a coral nursery, you have to maintain veterinary support. So you actually have to have a relationship with one of these 5 veterinarians who comes to your site regularly and does inspections and understands your biosecurity protocols and your disinfection procedures, and then they can sign off that your corals are approved for release. And it's just a visual inspection. Like we don't really know what causes the vast majority of coral diseases. So it's really the veterinarian coming in and going, yep, they look good, and there they go. But it's, tick the box. And then they're ready to go. So our staff does get the chance to actually plant some of these corals back out onto the reef. We do give the vast majority of our corals to other people to put back out onto the reef because we live in Tampa. It's not super cost effective for us to be driving 5,000 to 10,000 corals a year down to Southeast Florida and putting them on the reef ourselves. So we work with a lot of universities and nonprofits to do this work. And this is also happening not just at public aquariums and universities. So I just want everybody in this room to realize this is possible. There are people that are starting new nonprofit, non-governmental organizations that are doing this, and they are working with the regulatory agencies and following all those rules I just talked about, and are able to grow corals for release in Florida. And just a little update on our facility. These are those 3 greenhouses you saw earlier. We are currently under construction for a massive expansion that will put us to actually over 9,000 square feet with the spawning lab. So we're super excited about that. This is what it currently looks like. Yes, it doesn't have very many windows, and that is because we want to control ambient light in here. We shift the timing in our spawning tanks so that sunset happens in the afternoon, so we can actually do all the spawning work in our normal work day, and that just makes it a lot easier for us, so we don't have to stay up till 2 or 3 a.m. Every time we're doing coral spawning work. So this whole section of the building is light controlled and will be on probably a slightly shifted cycle to the natural sunrise and sunset time. And this whole wing of the building is for settling those offspring and growing them. So we hope to get up to 10 to 15,000 corals a year with this facility. And all of this work does not take place in a bubble. We have tons of partners that we work with, both in the regulatory agencies, universities, other aquariums, researchers. We also have some amazing industry partners. Aperture has been with us, every step of the way in terms of the lighting and helping us tweak things. Triton is amazing, and we send samples to them regularly and get a very steep discount on that. And Champion and Coral View, they are the people we can call and we go, oh, we have an emergency, we need this skimmer now. They've always worked with us. And you can learn more by watching these videos. The Florida Aquarium website has a ton of information on our program. And Richard has been putting stuff about us on reefs.com for years. Worldwide Corals came out and made a video recently. George Mavrakis also did, and Hillary was just out a week or two ago, and she will have a video on her waterlogged blog about our work and the Florida Reef Tract Rescue Project as well. So thank you for listening to me for, it wasn't that bad, like 40, 45 minutes, not even. Cool. Any questions? We can just chat. Yeah?
Well, first of all, congratulations on your efforts.
Thank you. I appreciate it. It's not saved yet, but we're trying.
Well, you know, I eat an elephant. One bite at a time.
That's right. That's right.
Same thing here. Once you've taken your colonies back into the wild, are you tracking them then in terms of growth? And I'm assuming that you are someday.
Sure. Yeah, it's part of all the permitting for that. Definitely, we're required to do follow-up monitoring. Each project is a little different, but it's usually for at least 1 year. And usually that first year, they do quite well. There's a few species that are like popcorn to parrotfish, and those are challenging. So we are working, the last thing you want to do is raise these things for a year and a half or 2 years, and then they get eaten by parrotfish in about 10 minutes. So that was difficult. So we're working on some predation deterrent devices for those particular species. But we've seen, even with the disease-susceptible species, they are doing well in the northern portions of Florida's reef. So because that area of the reef had this disease at epidemic levels all the way back in 2014, the disease has kind of blown through and is just now what's considered endemic. And we seem to be able to outplant these disease-susceptible species in those areas, and they are doing well. So there is promise. And one reason we really like to focus on the breeding of these corals instead of just fragmenting is because that gives you the diversity. So a species can't evolve unless it's able to reproduce. So by reproducing these corals and trying to increase the diversity in the offspring, we hope that some of them will be maybe more resilient in the future. Anybody else? Yes. Yeah, it's an interesting, so the question is about the slow-release amoxicillin compound. I am not a pharmaceutical formulator, and they use a lot of really big words, but I will try to explain. So they used a compound that is used to target drug delivery into like people's mouths and throats that actually supposedly shuttles the drug like preferentially towards mucus rather than water. So that is, the paste is applied along the dead skeleton, but right up against the living tissue. So it adheres to the dead skeleton that's new and white and clean, it's pretty grippy. And then it expands and kind of smushes into the tissue. And as long as there's contact, the theory is that that drug will be preferentially shuttled into the mucus of the coral. Mm-hmm.
So with the relief, now that they're putting the new coral back, there's not concern that it's going to keep that disease fed with new.
Sure. Totally valid point. So the question is, if we put corals back, isn't there concern that basically by giving more biomass of coral there, you could actually promote that disease coming back because it has more hosts available to it? And that is definitely something that is monitored, and we've monitored very closely over these past couple years, is if you go to an outplant site and outplant 2,000 corals, does that increase disease incidence even nearby? So not even necessarily in those corals alone, but nearby. And it appears to not be the case. We haven't documented that at all. It's kind of like, even what we're dealing with COVID right now, like now COVID is sort of in an endemic phase, similar to what we see with stony coral tissue loss disease in the northern parts of the reef, where you may still get little outbreaks, but it doesn't necessarily go back to epidemic proportions because a lot of the animals that are there probably have been exposed or have some level of resistance.
Are we looking at other parts of the world and other reef systems that are doing this, and are you guys monitoring that and seeing if they have success in doing the same kind of things?
Sorry, say that again?
Are you comparing your research to are they doing this on other reef systems in other parts of the world? And are they having success as well?
Yeah, so this stony coral tissue loss disease is now found throughout the Caribbean, and we work very closely with researchers in other countries throughout the Caribbean to try to help them build genetic arcs and do similar work. And then there's also, but this disease has not made it into the Indo-Pacific, but the Indo-Pacific has their own set of problems, which is climate change, and the reefs are still in trouble everywhere in the world. And there are many researchers now that have installed these spawning systems. They actually buy them from Jamie Craig's, and they've installed these spawning systems. And in Australia, there's a place called the CSIM that is doing very similar work. So a lot of scientists are now really turning to aquarium systems to learn how to try to save and conserve corals. So it really is spreading. And it's the knowledge of everybody in this room that supports the hobby and shares your observations that are going to give that background information in just coral husbandry that people will be using for decades to come to try to save corals. Wow. Is there a clown about to walk through the door?
Do you see a consistent pattern of the disease and then recovery, your efforts at recovery, region to region, like up north, where it happened first? Can you predict what's going to happen down at the south end of the Keys by keeping track of what happened up north and use that to tailor efforts, or is it just kind of a mixed bag?
It's kind of a mixed bag. There are some reefs that, for whatever reason, there are little pockets that didn't get impacted as strongly, and then there are pockets where 90+% of the corals are just gone. And we are not doing a ton of restoration work in the areas that are still epidemic. So because that is probably more detrimental to add more tissue into an area that's epidemic. So the majority of the work is happening lower Keys and northward, so not much in the Marquesas or the dry Tortugas, because that's still epidemic proportions. We still have a lot to learn, right? We don't know the best way to make up for this disease. And to be honest, it's actually impossible to replant all of the corals we lost. I mean, it's estimated just for the top 5 species, I think it was something like 9 billion corals. So to grow billions of corals is just not, and corals that you can't sell. So remember, you can't make money off of any of this because it's all illegal to sell. So it has to be funded by someone. So it's funded by either the state or the federal government. So to grow billions of corals is not really feasible. So what we're trying to do, and by we I mean the sort of restoration community as a whole, is to focus efforts on targeted reefs. So rather than putting the corals haphazardly throughout, it died, no. Rather than putting the corals haphazardly throughout the Keys, if you plant them all very close to each other on a smaller number of reefs, then maybe when they spawn, they'll actually be able to mix with each other and recover on their own. So we really need to get to the point where the reef can recover on its own. And cleaning up waterways and pollution and the climate in the meantime. Really, this is a stopgap. This is to prevent species from going extinct and keep that genetic diversity, and while we take decades probably to clean up our environment. On that very depressing note. All right. Thank you, everyone.